Hello and welcome to the Stu Know Who podcast. Early this week I experienced something, and it was an experience that was shared by millions of people, and something that I've been desperate to see my entire life. I've always had a fascination with space and all that stuff since I was a little kid. I was driving home on Monday night and I saw the Northern Lights, which I've never seen before. I've seen pictures of, I know people who've seen it, and it just looks incredible. Now, I live on the very south coast of England. The chances, or at least I thought, the chances of myself ever seeing that where I live was negligible. You know, it's not going to happen, but it's one of those things that on my bucket list, I'm going to one day go to Iceland or something like that and go and see them. I was driving home Monday night and there they were, and it was a gorgeous, beautiful shade of green, just like a streak across the sky. And I don't want to say mesmerising because I was driving at the time and I did make it home, so I was concentrating. But, you know, it was incredible to see, and it's definitely something I'm going to remember for the rest of my life, you know. Now, as I was growing up, Northern Lights was something you had to go abroad to go and see. Maybe northern parts of Scotland. Occasionally it might come down across the border into England, but definitely not as far down as I am. This is becoming more of a regular occurrence. I keep hearing people who've seen the Northern Lights coming further and further south. Whilst I'm fascinated with space, I am not a space expert. I'm not an astronomer or anything like that, you know what I mean? But it did get me thinking, like, what has changed? What is changing? Clearly something is. So that is what tonight's episode is going to be about. A little look at why this seems to be occurring more and more often, further and further south. And might throw in one or two tinfoil hat type theories as well, as I do on this channel. And if you like that kind of stuff, then please subscribe, hit the notification bell, and like the damn video. And let's get into it. So, what happened on Monday was a huge event, a huge solar event, and one that was seen by, it was Europe, it was North America, it was pretty much a lot of the northern quarter of the hemisphere or whatever. It was a lot of people saw this stuff who don't usually see it. So, this article reads from britbrief.co.uk. It was the largest solar radiation storm in 20 years, which sparked a spectacular UK aurora forecast. It was spectacular. It was gorgeous. When I saw it, there was no pink in it. It was just green. It was beautiful. It really was, and it kind of highlighted just how insignificant the problems on this planet are when you realise we are a speck of dust in the universe, you know what I mean? It's one of those things, when you see it, it does make you put things into context. We're living in crazy times right now. And seeing this was just, it was mind blowing. And when I got home and told my wife that I'd seen it, yeah, she was not best pleased, because we couldn't see anything from our house once I got home. But it was incredible. So, to continue with this article, the United Kingdom could be treated to a dazzling display. It was, as the planet experiences its most significant solar radiation storm in over 2 decades. The event, which began on Monday the 20th, is the largest of its kind since 2003. So it says it was a perfect storm for celestial light shows. This extraordinary event is a result of a powerful X-class solar flare. I thought X-class was a Jaguar, wasn't it? Anyway, and a subsequent coronal mass ejection that erupted from the sun on Sunday. The charged particles from this explosion are now colliding with Earth's magnetic field, creating a severe geomagnetic storm. The US National Oceanic and Atmospheric Administration confirmed the scale of the event, noting it poses an enhanced risk to aviation and satellite operations, particularly in polar regions. I'll just quickly finish this paragraph. So, for sky watchers, however, the primary effect is a chance to witness the aurora borealis much further south than usual. The aurora is forecast to reach a level 8 on the 9-point KP index, which measures geomagnetic activity, while the original forecast highlighted visibility across northern US states. Similar geomagnetic conditions often translate to spectacular displays over Scotland, Northern England and Northern Ireland, with the possibility of sightings even further south if conditions align perfectly. If I went any further south in England, I would be speaking French. I'm literally on the south coast. So to see it down here is... It was incredible to see, but the way my mind works, once I'd enjoyed the experience, once I'd fully taken in, my mind went to, but I should not be seeing that here. Now that article states that it can cause a problem. It can cause problems for electric phones, basically your power network, anything like that. What is happening with regards to the sun? What is happening with regards to the earth? That could cause something we're not supposed to see becoming quite frequent. Now, where I live, we have a local guy who does a lot of stuff on Facebook regarding weather, and he's also very keen on the aurora borealis. He's out all the time, and having spoken with him quite a few times, it's something he's seen a lot down here, especially recent years. I remember, I think it was 18 months-ish ago, my best mate, he'd gone on a cruise to Iceland. Dude earns too much money, clearly. I can't afford that. I wish him all the luck in the world, but if he wants to spot me next time, then sweet, go for it. But he went to Iceland specifically to see the Northern Lights. It's one of those things I know now. I can say once you've seen it, you'll never forget it. And I will remember where I was. I was actually driving past a pub, and I seemed to mark a lot of my monumental points in life by which pub I was near. Maybe that says more about me. But he'd gone to Iceland. It was cloudy, weather was awful. He saw Jack all the time he was over there. And while he was over there, it was hitting the south coast. I didn't see it. I saw the pictures of towns next to me. Even where I live, there were pictures, but I couldn't see it. But he travelled all the way over there to see it, and all he saw was rain clouds. I hope he got to see it this time. I will catch up with him and see. But that was 18 months, maybe 2 years ago, that this happened again, where right on the south coast of England, we could see the Northern Lights. Maybe they need to change their name, because they're becoming less northern, it feels. Now, maybe it's just the way that I have a very overactive brain, a very overactive imagination, and I do tend at times to catastrophize things. It just didn't feel that once I got over the initial euphoria of seeing it, the initial excitement, it didn't seem right, if that's the right word for it. It didn't seem like it should be something that should be happening down here. Which is the reason why I'm doing an episode on it tonight. One, to brag, I've seen the Northern Lights, but so have millions of people now. But it did make me question why. And that is what tonight is about. I want to have a little look through and maybe put some questions out in the ether, and hope I get shouted down in the comments where they say, dude, you're an idiot. Because good, it means we're all safe. So to continue on with this article, practical advice for UK observers. So find a location with a clear, unobstructed view to the north. Get as far away from city light pollution as possible. I was driving home through country lanes and one pub in the middle. Be patient, as rural activity can come in waves, and even standard smartphones can capture the light with a longer exposure mode. So, the science behind the solar maximum. Well, let's get scientific. So, this intense space weather event coincides with the sun's solar maximus phase. The peak of its 11-year activity cycle. During this period, sunspots and solar flares become more frequent and more powerful. So that might explain off the bat why we're seeing more recently. Jamie Favors, director of a space weather program at NASA headquarters, explained, during solar maximum, the amount of solar activity increases. This provides an exciting opportunity to learn about our closest star, but also causes real effects on the Earth. The coronal mass ejection responsible for the current storm is expected to continue affecting Earth into Tuesday, with conditions likely to weaken later in the day. Whilst the storm may cause temporary disruptions to high-frequency radio communications, it serves as a potent reminder of our star's dynamic nature and its ability to paint our night skies with unforgettable colour. For those in the UK under clear, dark skies, this week offers a rare chance to witness one of space's most magnificent visual phenomena. It was magnificent. It generally was. For someone like me who grew up obsessed with the skies, I don't know I sound like a right nerd talking about that. I know I do. But this was definitely something on my bucket list, and to see it in all its glory was amazing. So the sun is in a state where it's going to be dumping stuff out, and we're going to be potentially expecting more of these, and from that statement alone, everything seems a-okay. I don't tend to watch a lot of TV. I don't have time. But I have my phone with me, and I listen to a lot of podcasts, and I've heard a few people on podcasts over the last few months talking about this kind of stuff, and I don't know, maybe actually seeing it for myself made me question whether more is going on. Whether there genuinely is something to perhaps be concerned about. Or maybe just enjoy less. So, with potentially more of these things coming up, what is a solar storm? Now, we hear storm, we think rain, thunder, wind, whatever it might be. A solar storm, it's a storm coming from the sun. So, a solar storm is a disturbance on the sun which can emanate outwards across a heliosphere, affecting the entire solar system, including Earth and its magnetosphere, and is the cause of space weather in the short term, with long-term patterns comprising space climate. So the types, they include solar flare, so a large explosion in the sun's atmosphere caused by tangling, crossing or reorganizing of magnetic field lines. The sun is a giant ball of gas, and whilst it's been a while since I've done GCSE science, one thing I know with gases is they can be quite explosive. I mean, that's why the sun is so bloody warm and bright, like, you know what I mean? Because there's a chemical process going on there that gives out a lot of heat. So it's going to be volatile. A coronal mass ejection, which is what this was, which is a massive burst of plasma from the sun, sometimes associated with solar flares, and yes, we had them. A geomagnetic storm, so the interaction of the sun's outburst with Earth's magnetic field, and a solar particle event, also a proton or energetic particle. So to go to the Met Office, a bit of a deeper dive into space weather, what it is, and more importantly, what damage it can do. These aren't just beautiful lights. I suppose it's a bit like having a firework, isn't it? It goes up, it's beautiful, it gives you pretty colours. You got to make sure you know where that firework's coming down. You don't want to be stood underneath it and get doofed on the head. So, space weather describes conditions in space that can have an effect on Earth. So it's not just space stuff happening, it's stuff that directly has or could have an impact on us. I don't know if impact's the right word, because as soon as I said that, I just thought the film Deep Impact, and I'm like, no, this is it can have an effect on us. The most recognizable and visible space weather effect is arguably the auroras. So the northern and southern lights. Maybe it's because I live in the northern hemisphere. I didn't realise there was a southern lights too. I suppose it kind of makes sense, doesn't it? Yeah, I mean, they get the sun too in the southern hemisphere, but I think it's usually at the poles. So, however, as well as these spectacular natural phenomena, space weather also represents a real threat and can have an impact upon national infrastructure, technology, and communication systems. So I do know this didn't come out of the blue for me that we were potentially going to see the Northern Lights. I go out on a Monday night and I'm out for 5 hours. I rang my missus on the way home to say I'm on my way back. I was dropping a mate of mine off home to say might be a little bit late. And it was actually her that said, keep an eye out, you might see Northern Lights. I was like, cool. You know, there are warning systems there and alerts, and part of that is, you know, make sure stuff is charged. You know, because it can have an effect. You know, if you have a power surge at home, it's going to knock out your electricity in it, you know what I mean? And it's that kind of, be prepared. You know, make sure your electric stuff is either turned off or fully charged up or whatever it might be. And so we are good at, let's say the people who are monitoring this stuff are very good at saying this is coming our way and be prepared. So it says these effects can include interruption to radio communications and GPS. The amount of times bloody GPS has tried sending me down a one-way street the wrong way, or this is completely random story, and this is absolutely nothing to do with what happened recently. Years ago, I was driving a work van, and we'd had some quite substantial snow. My sat-nav sent me down this road, and at the end, it was a tight road, but my sat-nav is saying go through there, and the customer's house I was driving to was literally the other side. I was young and dumb at the time. There was probably a sign saying do not drive down here. I got halfway down and there was bollards. It had been pedestrianised, and then I tried reversing out and hit a sheet of ice and my van was stuck. I had to get towed out of there. I took the family to Longleat just before Christmas. It's kind of just after Christmas. It's, for those who don't know, like a giant safari park, animal safari park, and kids love it. It's great for kids. It's great for adults too. Proper going sidetracked here. But as you go up there with your sat-nav, there's so many roads, little country lanes, where your sat-nav tries sending you, and there's signs there saying, ignore your sat-nav, don't come down here. No access to Longleat. So we have issues enough without bloody solar flares and storms knocking out. There was a point to it. I'm just saying, maybe we need to go back to maps. So, yeah, GPS, disruption of power grids and damage to spacecraft. The impacts are caused by magnetic fields, radiation, particles, and matter which have left the surface of the sun and interacted with the Earth's upper atmosphere and magnetic field. The Met Office Space Weather Operations Centre, I can see why they've abbreviated that, because that's a mouthful. So, MOSWOC, sounded better as the mouthful, provides critical information to help build the resilience of UK infrastructure and impacted industries in the face of space weather events. So, what does cause space weather? It is a consequence of the behaviour of the sun, the nature of Earth's magnetic field and atmosphere, and our location in the solar system. The active elements of space weather are particles, electromagnetic energy, and magnetic fields, rather than the more commonly known weather contributors of water, temperature, and air. So magnetic fields, radiation, particles, and matter which have been ejected from the sun can interact with the Earth's magnetic field and the upper atmosphere to produce a variety of events, such as the aurora that I saw. But this stuff can knock out electrics, knock out communications. Beautiful, but you need to take it serious, or you as an individual perhaps not. Make sure stuff's charged up, but it's something that it's monitored closely, because I mean, look at the size of the sun, look at the size of the earth, you know what I mean? The effect that this giant ball of radiation and gases can have on our tiny little rock that is spinning around it, of course it's going to be huge. I mean, the whole fact that we spin around it, you know, because we are in its gravitational pull, that just shows how important it is to us and how insignificant we are to it. It is a ball of gas that is always having some sort of reaction. It's a giant fire in the sky, you know what I mean? If your next door neighbour's house was on fire, you'd be worried if it spreads to yours, you know. That's the kind of principle. This is what the sun can and does have an effect on us. It's why we have sunburn. It's why we have spring, summer, winter, autumn. You know, our relation to the sun is in a different place, you know, and still asking questions at this point as to why are we on the south coast seeing more and more solar flares. I know they said it's more, the sun is in its active period every 11 years. That would mean that 22 years ago, see that math then? It's clever, isn't it? 22 years ago, we should have been seeing southern flares, northern lights in the south. I don't recall that. Maybe we were. You know, especially before I had a wife and kids, I've enjoyed my life. You know what I mean? So I don't know. Maybe it was going on, but I was oblivious to it. Tell you what, having children, it does make you more cautious, more alert to what is going on. But I don't remember 22 years ago this kind of stuff happening. I'm sure until recently, and by recently I mean the last 3 years maybe, the actual concept of seeing the Northern Lights where we are seemed completely alien to me. So I'm gonna continue digging in this episode and see what we can find. So, sun activity increasing, what that means and why we should pay attention. This is from NASA Space News. I would like to think they might know what they're talking about when it comes to space. You kind of hope so. I mean, if they don't, what chance have we got? You know what I mean? So, the sun activity increasing. Long thought to be heading toward a quieter era is surprisingly waking up. And the consequences may ripple throughout space and even here on Earth. Recent scientific research shows that solar activity, after decades of decline, has reversed course. This article explains what that means, the science behind it, why it's important, and what lessons we should draw from this shift. So, new research confirms that several metrics of solar activity began rising since 2008, ending a long-term downward trend. 2008 was how's your maths? 18 years ago. That's close to that 22 years that I mentioned on the last section. So, a study published in the Astrophysical Journal Letters reports that after the sun's activity bottomed out in 2008, in what was the weakest solar minimum on record, indicators including solar wind speed, density, temperature, and strength of the interplanetary magnetic field have all increased. Moreover, news pieces summarising this study emphasise that solar activity is on an escalating trajectory outside the boundaries of the 11-year solar cycle. So this article states there, and I said on the last section about the 11-year cycle, the trajectory is outside of that. This is not what is expected, not what would have been predicted, assumed. This is something peculiar, different. Reason to worry? Probably not. But as I said earlier in this episode, I am, especially now I'm a father, you hope for the best, you prepare for the worst. And the way my mind works, I know I do tend to catastrophize. It's something I'm trying to work on, but when every time you turn on the news there's a new bloody war or something kicking off, it's a bit hard to get out of the mindset, you know what I mean? But this is outside what was expected, the usual, the norm. So, the article continues, the solar cycle, roughly 11 years, has peaks and troughs of activity. More sunspots, stronger flares, etc. At peaks, and then quieter at minima. From the 1980s through about 2008, each cycle appeared progressively weaker. Scientists speculated the Sun might be entering a grand minimum, which is a prolonged, decades-long lower activity stage. But data since 2008 show the Sun is growing more active again. The changes are not just within one solar cycle, they appear to span longer timescales. Recognizing this change is critical as it alters expectations regarding space weather, satellite safety, and how we model the Sun's behavior over decades. Now, on a related note, but a different topic, we are, especially in the UK, going very, 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 very hard on the green stuff. I want a lovely, clean planet. I want a bright future for my kids. I want a prosperous, peaceful world. I think with something like this happening, you have to really realise that it doesn't matter what you do. If the Sun says it's going to be more active, if it heats up or whatever it does, you can have all the windmills in the world. It ain't going to do crap. So should we be bankrupting ourselves as fast? I try not to get political with this one. Just a side note there. The Sun has such a monumental, huge effect on our planet. So the science behind it, how do we measure solar activity? So various physical measurements provide insight into how active the Sun is, and recent trends show many of them rising. According to the NASA-led study, the solar wind velocity has increased by about 6%, density by 26%, and temperature, which goes to what I was just saying, by 29%. That's over a quarter. That is a lot. And the strength of the interplanetary magnetic field by roughly 31% since 2008. These are major shifts in solar output and magnetic influence. Also, frequent strong solar flares have been observed in recent years as catalogued by missions tracking solar behaviour. Solar wind is a stream of charged particles continuously flowing from the Sun. Its speed, density, and temperature reflect how energetic or magnetically turbulent the Sun's outer layers are. The interplanetary magnetic field is what the solar wind carries outwards, and its strength corresponds to how much magnetic disturbance the Sun is pushing into space. Stronger IMF and denser, hotter solar winds mean more energy and particles that can interact with the Earth's magnetosphere. Understanding these measurements help us predict what sort of space weather effects might be coming. So that's basically how they know what might be coming our way, and those alerts about, potential solar flares coming. That's how they know, I'm guessing. Now, they mentioned the temperature quite a few times then, and just to go back to what I was saying, how much effect does us getting rid of gas boilers to have a heat pump that doesn't heat house properly? I used to be a gas fitter, so I kind of like to think I know a little bit of what I'm talking about. Only a little bit, tiny bit. How does that actually affect what that big yellow thing in the sky does? Although the Sun actually isn't yellow, it's more of a red colour, I think. If that thing is heating up, so are we. You know what I mean? I'd love to send Ed Miliband there, go land on the sun, have a little word with them and say, turn it down. That could solve a lot of problems. And there's a few people could take with you as well. The sun is becoming more active. Without the sun, we wouldn't be here. Without our proximity to the sun, we're in the Goldilocks zone, they call it. When they're looking for extraterrestrial life, it's the Goldilocks zone. Not too hot, not too cold. Perfect. That is where we are. That doesn't mean that it's a steady temperature, solid all the time. We had, looking back, the medieval warm period, where temperatures were hotter than they are today. I need to have a good look at that, but I've heard that in several places, temperatures were actually hotter during a period of the medieval times than they are now. They were not industrialized back then. Unless horse crap was causing the temperature to warm up, and now it's chimneys. But it's every time I hear this, I'm like, I'm not saying global warming is not happening. I'm not saying man-made global warming is not happening. I'm saying there's a big yellow thing in the sky, and we have history of the world getting warmer and colder before we industrialized, and nobody seems to speak of this, or at least nobody in the mainstream media or politicians, because it's not fashionable. You know what I mean? So the fact that the sun is getting more active, we know what effect it can have on us. I saw it for myself on Monday night, and all I saw was something that was beautiful. I felt lucky to have seen it, because it's something I've wanted to see for so long. But if we're going to not look at what the sun could do, or what the sun does do, or potentially the way our Earth interacts with it, or what is going on our own planet, if we're not going to look at that, I think we're missing a trick there, in my opinion. So, speaking of our own Earth, this was a story from last year that I've pulled up on X. Now I'm going to go slightly tinfoil hat with this. But since 2020, I've definitely started questioning things a lot more. I'm more cynical. I think after what happened, I think that's fair. And I remember seeing a jumper worn by someone that said, if you trust the government, you don't know history. And I thought, that's class. I love that. And that came out 2020 or post 2020. I've always been the type of guy to question stuff, but I think with the virus, with Jeffrey Epstein, there's two examples right there where you think, trust these people if you want, but I'm skeptical. So, yeah, I don't know whether you call it tinfoil hat or awake. Just not trusting people blindly because you're told you should. So this post on X is by an X user called Synchronous. I searched the story. I don't follow this guy. Don't know his politics. I don't know who he is. I'm not saying he's irrelevant. I'm saying to this story, all he's done is highlight it. Thank you for highlighting it, because I was looking for it. Because I remember hearing it and thinking, that's quite interesting. So his post is MIT plasma scientist Nino F.G. Livero was shot inside his home late Monday in a killing authorities are now investigating, as a homicide. So his field of research, Earth's magnetic reversals, in brackets, polar shift, which I believe was the plot for the 2012 film, which it's an alright film. It's alright. I'm not going to say it was a great film, but it is alright. You know, if there's nothing else on, it's worth a watch. But to do with polar shifts, he warns in this video before he died that Earth requires periodic magnetic reversals to sustain its fields. Without the action of reversal and dynamo, the magnetic field would dissipate. The last time a reversal happens, Noah's flood. So I am going to pull up this video.
Yep. So my question is, in the last slides, you mentioned that the Earth's magnetic field was constant in the last billion years.
Roughly.
So, yeah, is it right that the Earth has lost 10% of its magnetic field in the last 150 years? And how come?
So, excellent question, Alec. Thank you. So, when I say the Earth's magnetic field has remained roughly constant, what I mean is, if you look over longish timescales, its magnitude is roughly constant. So of course, it varies, right? And it reverses sometimes, right? And those reversals of the Earth's magnetic field, so, you know, reversal meaning the North Pole becomes the South Pole and vice versa. So those happen, and there's even interesting stories you can tell about how those reversals of the Earth's magnetic field correlate with mini ice ages and things like this. Okay, but the idea is that if you average over these periodic reversals, right, or fluctuations, the amplitude of the field has remained roughly constant. Okay, and the idea is that if there was no induction, if there was no dynamo working, you and I wouldn't be talking, right? The magnetic field would have diffused very quickly, right? Within 10 to the 5 years, the Earth would be left without a magnetic field, and the Earth's magnetic field protected from cosmic radiation, right? And if you were open to that radiation, you wouldn't be here, like I said, nor would I.
Yeah, thank you.
That's scary, isn't it? See my intellectual input there.
Thank you very much.
Great, and I think we have one last question, so I'll just give them.
Hello.
Yeah. Hi.
So my question was, where exactly at using quantum computing in plasma physics problem, as quantum computing is pretty new, right?
Yeah. Great question.
So how can we use it in plasma physics?
We can't. Okay. So the short answer, we cannot. Okay. The longer answer is that, you know, people are thinking like this. People are thinking it may take 20 years for there to be a quantum computer that one can use, right? Like one that actually is useful for something, for solving a real problem, right? And it's a mistake to wait 20 years and then start thinking how to use it. because it's not going to be about taking a code that I have and just porting it to the quantum computer, right? That's not how it's going to work, because it's a fundamentally different architecture. So what people are thinking is, yes, it will take 20 years to get a computer, but it probably will take 20 years for us to understand how we can map our problems into something that can be solved on a quantum computer. Right? So the idea is to have the two lines of thought develop in parallel, so that by the time that there is actually a useful quantum computer, we are ready to use it. Okay, and it's actually a very challenging problem, because, like I said, all our problems are nonlinear. It's not at all obvious how you devise a quantum algorithm that will allow you to solve nonlinear problems. So, for example, an example of something.
Just to interrupt quickly, I just want to remind anyone watching that this was a video that the guy who was murdered, I don't know if anyone's been caught. I probably should have checked before I'd done the podcast, but his whole thing was looking at polar shifts and way of projecting it, protecting against it, and seeing what could happen. He's talking about what do we call them? Clever computers that will do it. They'll work out the stuff. But he was murdered shortly after this. It could have been an estranged lover, could have been an argument, burglary. I don't know. I just think with my tinfoil hat on, it was interesting that someone who was talking about the Earth's magnetic field and potential polar shifts and stuff like that was unalived not long after the release of this video. So continue and let people a lot smarter than me talk.
I'm playing around with is called the Madelung transformation, which is a transformation you do to the Schrodinger equation that maps it into fluid-like equations. That's very interesting. Okay? It has limitations, but it's very interesting because our MHD equations are similar to those. Okay? So this gives you an idea of the type of mapping that you can do to some problems that might make them easier to solve on a quantum computer. But it's a completely different way of thinking to what we do currently with conventional computing. Like, you don't think like that for conventional computing. So that's the answer.
Thank you.
Yeah, I think that's also, with that said, I think we can close this session. Thanks again for the very interesting talk.
So just to read what is on that statement. So it's a statement of the Earth's magnetic field. Let's assume that a magnetic field was present when Earth formed. The Earth's outer core is an MHD fluid. From its properties, we can estimate whatever that is. But from paleomagnetism, we know that the strength of the Earth's magnetic field has remained roughly constant for a long time. So the magnetic field must be actively generated. A lot of that is over my head. I'll be honest. I will be honest. But he was someone who was looking into a potentiality for polar shift. And he was unalived not long after. And do you know what? My head says it's probably a coincidence. But I'm going to quickly look into a polar shift and what kind of catastrophic impact that could potentially have on us as human beings. So this is on BBC, the sciencefocus.com. So Earth's magnetic field is overdue a flip. It's overdue. Should we be worried? From time to time, the Earth's magnetic poles flip, leaving us without a protective magnetic field for up to centuries at a time. which means all that radiation from the sun is, you won't need sunbeds no more. Put it that way. So what causes the Earth's magnetic field? They are generated by electric charges in motion. In a bar magnet, the moving charges are electrons orbiting in atoms. In Earth, there are electrons ferried around by circulating currents of molten iron, so beneath the ground we stand on. The details are not well understood, but basically, hot material in Earth's outer liquid iron core expands, becoming less dense than its surroundings, and therefore rises. Cooling and becoming less dense, it should sink back down again. But the Earth's rotation prevents this. Consequently, liquid circulates around the core, and friction between its different layers charges them up, just like a plastic cone rubbing against a nylon sweater. If these moving charges that generate the Earth, it's these moving charges that generate the Earth's magnetic field. The two requirements for planetary magnetism are therefore a liquid core and a rotation, which we've got. We know this because Venus, which is roughly our size, has essentially no magnetic field. It has a liquid core but rotates slowly. So why do Earth's magnetic poles move, and is the film 2012 actually potential? So though the Earth's magnetic field is very similar to that of a bar magnet with a north and south pole, it is not as stable because it's generated by complex processes inside the Earth. These cause the magnetic poles to wander. Historically, the North Pole has moved about 15 kilometers per year. But since the 1990s, it has sped up and is now moving about 55 kilometers per year towards Siberia. That is a big speed up. It's speculation, but this might foreshadow a magnetic reversal in which the magnetic north and south poles change location. Sounds crazy, but this has happened 171 times in the past 71 million years. So it's not regular. It's like the bus route where I live. It's definitely not regular. But it does say we are overdue a flip. Models of the Earth's magnetic field based on satellite observations have shown that the present wandering is the result of a battle between blobs of unusually intense magnetic fields deep inside the planet. As for the flipping of the Earth's magnetic field, nobody is 100% sure why this happens, but it does. What would happen if the magnetic field disappeared? Scientists discovered magnetic reversals by measuring the magnetic field on either side of mid-Atlantic ridges from which molten rock is extruded like toothpaste from a tube. As it solidifies, its crystals align along the direction of the Earth's magnetic field at the time, leaving a tape recording of reversals, so they can trace it back and they can see that it does happen. Reversals are believed to take place over 1,000 to 10,000 years, during which time the field shrinks to zero before growing again with the opposite polarity. There were therefore times, maybe even centuries, when the Earth had essentially no magnetic field. This is dangerous for life, since the planet's magnetic field extends far into space and creates a protective bubble around Earth, shielding the planet's surface from the hurricane of particles of the sun's solar winds and higher energy cosmic ray particles from deep space. Basically, were this to happen, we got some issues, man. That might be worse than a war. You know what I mean? Were that to happen, we basically would be at war with the sun. And there's only one winner there, I'm afraid. So let's hope and pray that doesn't happen. Now, before I wrap up, do you know what? To go back where this episode started, I've been desperate to see the Northern Lights. And I'm so happy I saw them. I am. They were beautiful, so let's throw some pictures up. And let's leave on a positive note. Now, I'm not going to point out which one is mine, but let's just say one of these properties in this picture is the property where I live. This was above my house. Now, when I got home Monday night, I can see none of this, but I could see that green on the way home. And do you know what? It was beautiful. And I want to see it again. But it makes me ask questions. Again, one of those houses is where I live. And that's just up the road for me too. It was incredible seeing it. I just hope that everything's all good, like, you know what I mean? I hope I've seen one too many films and maybe smoked one too many doobies in my life. Anyway, I'm going to wrap up here because I'm going to go and look up and see if I can see anything. Thank you so much for watching. Please subscribe, hit the notification bell, like the damn video. You can watch me on YouTube or Spotify at Stu Know Who. Follow me on X at Stu Know Who. Thank you so much. And until next time, I'll see you later.